All right, welcome everybody. Looks like it is 12:30, so hopefully everybody had a chance to get something to eat before this talk got started. We have plenty of room in the middle, so if you're on the ends, you're welcome to move in more into the middle. If you want to stay in the end, that's totally fine. So we still have a couple people trickling in, I see. Just to get started, my name is Andrew Hall. I'm the program manager lead for all of the tools that come out of the .NET team. So that includes the compiler, language services, the project systems. So when you open a CS proj, a VB proj, or an FS proj, the thing that lets that work inside of Visual Studio, the web tools, so the editors for Razor, CSHTML, VB HTML, CSS, HTML, JSON, and then our Azure App Service tooling that lets you work with all of the services in Microsoft Azure App Service. So being a lead basically means that I have a lot of people on my team that work really hard and I get all the credit for the great work that they do. Yeah, so hopefully everybody's enjoying Orlando. Nice and a little more humid here than it is in Seattle right now at this time of the year. So nothing like walking out and feeling like you've taken your second shower of the morning. All right, so let's go ahead and get started this morning. So quickly we'll go over the agenda for what we're going to talk about. So I'm talking about considerations and design patterns, or the title of the talk is Developing for the Cloud Using Visual Studio. So we're going to talk about what are the things that we think about and should consider as we develop for the cloud. So why develop for the cloud, basically. Then I'm going to talk about Azure App Service. As I mentioned, my team is responsible for the tools that let you target App Service. And we think App Service in general is the easiest, best place to get started developing for the cloud. And there certainly will be times where you will need to move on to other parts of Azure, and Azure has tons of great services beyond Azure App Service. We think in general, as a getting started experience, if you're not already doing cloud development or it's something that you're new to, App Service provides the simplest, best experience to onboard to that. I'm going to talk about some of the great new diagnostic capabilities that we have in Azure for .NET applications. We're going to talk about how to set up continuous delivery and integration pipeline, so CI/CD. We'll talk about serverless computing or Azure Functions. Hopefully everybody's heard of that, but if not, we'll talk about that a little bit. And then finally, we'll talk about containers. Overall, what you're going to get from me today is kind of a 5,000-foot survey of a bunch of different things in Azure. So if you're already an expert Azure developer or you've been doing it for a long time and you're familiar with a lot of the new stuff that we have in .NET, I'm not offended if you choose to leave. I want to set expectations appropriately. And then at the end, I have a slide with a bunch of other talks that will help you dive more deeply into a lot of the things that we're going to talk about. So this is kind of going to be an overview course. The other thing I will mention is what you're going to get from me is a very filtered, opinionated view on a few Azure services and a few technologies that I would recommend and that we on the .NET and Visual Studio teams would recommend for getting started with Azure and for thinking about from a design pattern perspective. I will have to add the disclaimer that just because I don't talk about something doesn't mean it isn't cared about, isn't loved, and isn't important. So please don't read into my silence on something, for example, that it's something that's going to go away or it's that we don't care about. I'm just starting from a sort of opinionated perspective. We only have 75 minutes today. That sound good? All right, so first thing I want to start with is just a pointer to some content that we have available via our website, .NET.architecture. One of the things we heard from a lot of people was, hey, we want guidance on how do we architect modern cloud-based applications. So if you go to this website, .NET/architecture, we have ebooks and we have samples available. So there's like a 290-page ebook that's available for download for free. And it's going to guide you through thinking about how to architect and do a bunch of design patterns that I'm going to talk about today. And it's obviously going to go much more deeply than we have the time to go for today. So, and it's available for everything. So I mentioned that microservices is the thing that I'm going to talk about a lot today, especially as the cloud. But if you do mobile applications, if you do Windows applications, there's architectural guidance for that there as well. And these slides should be available for download after the conference. So if you want to grab them and get all the links, you're very welcome to do that. All right, so let's go ahead and kick off the conversation, and let's start with why do we want to develop for the cloud? Just out of curiosity, how many people here are already targeting some cloud? Okay, good percentage of people. So hopefully a lot of this will be review, but one of the things that we believe that the cloud gives you is we believe it gives you better agility because it gives you a better deployment stack, right? The cloud, there's thousands and thousands of people working on building a great cloud platform for you. If you're on your own infrastructure within your own organization, you're always struggling with a small team of people trying to keep up, trying to get things set up, trying to maintain modern infrastructure. And because the cloud is theoretically, depending on how you set it up, public facing for anyone and everyone, it really enables you to have good DevOps practices using continuous delivery. So that means your developers, right, can be really engaged with the application in production as it goes. It enables growth enablement, right? So if you have a new project that you want to do or something that's really popular and you need to stand it up, it's really easy to scale, right? It's because the cloud infrastructure is always there and you only pay for what you consume. You can take advantage of it when you need it. And then there's a bunch of great stuff baked in that we're going to look at in the insight and analytics space that the cloud platforms, especially Azure, are bringing to the party these days. And then overall total cost, we believe, is lower for going to the cloud, right? You're not maintaining your own internal infrastructure as you go, and you're not maintaining it, right? It's expensive to maintain data centers, maintain physical machines. So with the cloud, when you go to Azure, you really only pay for the things that you use. So one of the things that you'll hear us talk about a lot about microservices, and that's in comparison to what we would call traditional application design. So traditional application design typically contained a few processes. You probably had your application factored into a bunch of libraries, and then you probably had only a few layers. You probably had a client, a middle, business logic layer, and then your data layer, kind of the traditional three-tiered app. Maybe you had a couple extra ones in there. And what that means is that when you want to scale that application up, you have to scale the entire app by spinning up a new instance of a virtual machine or running it on a new server. So here, the little colored boxes, you can think of them as libraries or logical components of your app that are factored into a single application. So let's say the red one is getting hit really, really hard and it's totally hammering the server. You're going to have to spin up a new VM in order to make that application scale to meet the needs of your customer, even though green and blue may be getting the green and blue libraries or portions of the app may be getting very little usage as you're going. So in comparison, one of the design patterns that we recommend as part of modern cloud development is microservices. So the idea behind microservices is that they segregate functionality into separate, smaller services with well-defined communication protocols. For example, HTTP, message buses, et cetera. And then what happens is you're able to scale that by deploying each service independently with multiple instances. And it helps you improve your speed of iteration because when you want to change portions of the application, you're only affecting a smaller portion of the application. So if you think back to our previous graphic, if I want to change the green box that may not be getting a lot of use, I'm theoretically redeploying the entire app, and I'm potentially putting the red and blue boxes at some small level of risk because they're all running within the same process. So if for some reason green starts misbehaving badly due to a change, that's going to take down potentially the entire app. It enables testing and isolation. So as we spin these things up into smaller processes and have well-defined protocols. And the other thing that it does, which I don't have listed on the slide, but it actually makes the technology that you choose less interesting from an application interaction perspective, right? So it becomes very easy with well-defined protocols in between, if HTTP, message buses, or other things, right? Node, Go, .NET, .NET Core, Java, they're all able to communicate over these protocols. So you're able to take an application, you can have a team of people, they can say, oh, we prefer to work in Python. One team can prefer to work in Go, one team prefer to work in .NET Core, and they're all, by exposing HTTP endpoints or agreeing on the way that you're going to communicate, you're able to have an application that is heterogeneous in terms of technologies so everybody can work using the technologies that they prefer to work because the only thing that matters is the contract that is in between, right? When you go to a web page, You don't really know what's running on the back end. You just know that it spits out HTTP, and at the end of the day, that's a standardized protocol. So what does microservice design look like in practice? Right? So the idea is we would take all these little logical units of the application, and then we would split them up and potentially mix and match them as they need to interact, such that each microservice would have its own logical unit of work that it would be responsible for doing. And typically you would want to keep data isolation. So if you're going to have a particular database, for example, that contains certain types of data, that would be contained entirely within one microservice. You typically wouldn't have multiple microservices trying to modify the exact same database. But what this enables now is, let's say we want to spin up, just replace the top one, that's our front end for the user. We're able to just replace the front end for the user without bringing any risk for any of the back end logic components. Or if the bottom middle one for some reason gets really hot and is getting hit really hard, we're able to spin up more instances of that. So what it does is microservices give us fine-grained density of services. So hopefully we're only scaling up and paying for instances of services that are actually being used at a time. And so then each service is scaled and deployed independently. So a couple other concepts I want to talk about before we actually get to the demos, and then I'll hopefully spend most of our talk going through, is secret management. So when I say secret management, what do we find as an application secret? An application secret is data required by your application to access secured resources. An example of that would be database connection strings, APIs, etc. And so typically, you're going to have different secrets that are going to travel with your application. You're going to use different values as the application travels through your pipeline from your developer machine into production. Right? A lot of times your database connection string may be not secret at development time. You don't really care. It's a local SQL Server local DB. Nobody else has access to that. Even if they got the connection string, it doesn't really matter. But as soon as you get into staging or production, that connection string is really critical and it needs to be protected. But as a pattern in practice, we would typically not recommend that you store secrets in source code and that you adopt a pipeline. And I'll actually talk about some tools that we have for that at Microsoft and Azure to help you sort of easily just swap out where you're storing your secrets as you're developing your application. So with that, let's go over to the demo machine, which has gone to sleep. All right, I'm going to go ahead and kind of sit down on one of these chairs so I'm not hunching over the desk the whole time. So the first thing I want to talk about, so what we're going to do for today for our application is, for our demos, is I thought we would build a small microservice-based application. At home, my wife works 2 days a week, and so we have a nanny. And I haven't really been able to find a payroll service that I actually like. So I have to pay her, I have to take out taxes for that. So I've decided to build my own in Azure. So it seemed like a nice application that would give us the opportunity to have a couple microservices. And so the first thing that I want to do as part of that is I need a web front end that's going to let me generate her pay stubs. And since we only have 75 minutes today, I figured we'd just focus on the employer portion of this, kind of the employee data is stubbed out right now. But the first thing I need to do is I need to introduce the idea of authentication into the application. So I need to know who's logged in so I understand who the user is. So the way that I'm going to do that, and I'll go ahead and use Edge for my own app and Chrome for working with the Azure portal so I don't get too confused, is I have stood up an instance of what's called the Azure B2C. So if you haven't heard of this, this is a service in Azure that they handle all of your identity configuration for you. And so all my application has to do is understand how to connect to the instance of the Azure B2C authentication. And the service on Azure handles everything. It handles sign up, sign in, and I simply connect to that. So I've already stood up an instance. So it forces me to create my own domain. And so my own domain in this particular case is Andre Hal. That's my alias at Microsoft. So Andre Hal Ignite on Microsoft.com. And so when I switch to that tenant, here for a second. I'm like trying to make the internet go fast at a conference. All right, well, while that's thinking about it, I will flip back to Visual Studio and show you how you connect to an instance. So I already have my application, it's already connected. But if I wanted to add a new one, when I say add new project, and everything I'm going to do today, with one exception, is going to be ASP.NET Core or .NET Standard. So I'm going to create an ASP.NET Core web application here. And then to connect to my Azure B2C instance, let's see if it's decided to come up yet. All right, perfect, it's here now. So you go in and you create it, and then you basically just stand up new applications, and it gives you this idea of an application ID that you then use from your application to connect back. And so in Visual Studio, what this would look like is that when I click this Change Authentication button, and it gives me multiple options for working with authentication. In this case, I've decided to go with, as I mentioned, Azure B2C. And let me change the type of the app, because that actually changes the authentication options. But for this particular case, I'm going to say I want to just connect to an existing store in the cloud. And my domain name is andrehallignite.on.microsoft.com. I would go grab my application ID out of the portal, which I've already done for this particular application. And then you just create a couple sign-in policies. So under here, you create a sign-up or sign-in policy. I have two sign-up or sign-in policies, a profiling editing policy, and a password reset policy. So I would plug these particular names that I've defined. And this is actually pretty slick, so it's worth showing. So when I say Azure B2C_1 default, and I edit my policy, I can just go in here and I can decide what do I care about. So email, and I'll show what that looks like in a second. So I can define the attributes that I want collected from the user, and I can define custom attributes. So this user role down here is a custom attribute that I've defined in the Azure B2C tenant. And then I can do the application claims. So these are things that will come in the authentication token, and I can choose the ones that I want to get back in the token as the user. And so then down here, I can even go in to customize the UI. And so when I say local account signup page, for example, the user role, so there's going to be two roles in our payroll application. There's going to be the idea of an employer, and there's going to be the idea of an employee. And so I can go ahead and customize this, and I can say I want the label to be role, I want it to be a dropdown, and I want the values of the dropdown to be employer, employee. And so this is all configured as I mentioned, but I would, in Visual Studio, I would plug in the application ID, I would plug in the name of those policies, which were B2C, and this is generated, that part's generated for me, _1, _default was the name of that one, for example. And then at the end of the day, when I get an application, I'll cancel out of that because I already have this one. You'll see here in my app settings that it basically generates this Azure B2C section that inserts all that information for me. So it just, Visual Studio is generating the default template for me as a user. And now when I go here to my index page, I'll quickly stand up, hit a breakpoint, and we can actually look at the user information. And you should see, so let's go ahead and say debug, start new instance. And as that spins up, when we hit that breakpoint, you should see all of those claims that I checked in the Azure checkbox for all the information that I wanted, just telling me associated with the particular user token after the sign-in completes. So as I mentioned, I was going to use Edge for my own application. Perfect. And so now I'm not, let's see if I'm signed in currently. I'm not signed in currently, so when I hit F5, I'm going to expect that I need to sign in. So now watch this. It's going to take me over to the B2C portal. So now it's redirected my application from my application over to the service that's owned by Azure. So I'm going to go, so if I wanted to sign up, I'll go ahead and open this in a new tab. I already have an account. But as I mentioned, they're handling all of this for me. So I plug in an email address. It has to be a real valid email address. You click send verification code, emails you the code, you plug it in, pick your password, pick your role. This is what I showed before. So I have to pick whether I'm an employer or an employee, and I sign up. In this particular case, I already have an account. So there's my email address. If anybody wants to email me, feel free. And now when I click sign in. What's that, sorry? Oh, thank you. Why is it not happy? the space. No, that's right, andrew.hall@microsoft.com. You know, the one rule of demos that I have learned is something will always go wrong. It doesn't matter how many times you there we go. I don't know why it wasn't happy. But now as the user, we can see that the claims here, when I enumerate them, these are all the things that I asked for. So it has my email address, it has my role, it tells the app that I'm an employer, it has my name, and it has some other things that Azure includes by default. And so when I hit F5, you see that it should redirect me. And now it's going to try to fetch the employees that I have, but I haven't actually stood up the service that it's trying to call, so that exception there is expected. Perfect. So that was, if you think about what I just did, I'm going to stop and point this out because it was pretty quick, but I may have missed it. I saved about 3 minutes worth of work of not watching you have some dots spin in the portal while it created those things. But if you think about, if I was going to roll my own service to handle user management, I would have had to stood up a database. I would have had, in order to be compliant with a lot of the new rules coming, have enabled encryption on that. I would have had to do a lot more work than I just did. And so by working with the Azure B2C authentication service, and they also have AAD services if you're domain joined, within the matter of a few minutes and file new project, plug in a couple values, I'm able to have an application that is standing on a service that's fully compliant, fully managed, fully secure, and handling the authentication and the identity of my user secrets. So as I mentioned, we wanted to go microservices. So in this particular application, I have two services right now. I have an employer portal, and then I have an accounts portal. And so what I've set it to do is I've set it to, so if you're not familiar with this in Visual Studio, it's a little tip, but you right-click on the solution, you can choose multiple startup projects, and you can choose the behavior that's going to happen. So in this particular case, I have API accounts. That's my back-end web API that's going to be authenticated. So the Azure B2C supports token authentication, so I'll get a token and I'll pass that to the API accounts. And then the employer portal, so I want both of those to start. All these other things are class libraries, so they don't need to start. So I'll click OK, that looks good to me. And so now, when I'm going to start this application without debugging this time, because we don't need to verify the user claims that were added into the application, I should see that it'll spin up. It already knows that I'm signed in, and I can see that I have one employee associated with me that it's retrieving from that back-end web API called John Doe. He currently has 16 hours, and I can click a button to generate his pay stub, and we'll get to that for a little bit. So one of the things that I mentioned a minute ago was the idea of user secrets. So as a user, one of the things when developing for the cloud is it can be kind of a pain to deal with different configuration options, because there's certain things that we would recommend not going into source control. There's certain things that don't naturally travel with the application. So ASP.NET Core, which is where we're starting today, by default, we store the application settings into the app settings.json file. But this file does not travel with my application when I publish it. It's designed for local purposes only. So what's a way that I can work with my configuration settings in a way that as I move, I really only have to flip like 1 or 2 values, and my application will be getting all the configuration updated values as it travels from a local environment to a dev test environment to a staging to a production environment. So the way we would recommend doing that at Microsoft is we would recommend using an Azure Key Vault. So Azure Key Vault, how many people are familiar with that? Okay, a few people. So the idea behind Key Vault is it's a service in Azure, and I already have one created up here, so we can go take a look at this. So my Key Vault, so the idea behind a Key Vault is it's a vault that encrypts and stores keys, and then your application can access it. And so the only thing your application needs is all it needs is the settings for understanding how to connect to the Key Vault, and then all of your other configuration settings. Typically it's designed for secrets, but I actually find it's really convenient for all settings that you would want to change as your application travels through production, because it means that all you have to do is change the key that your application points to, change that name of that vault and potentially the credentials that are associated with it, and then all the other configuration can be set in the Key Vault. And this is especially true as we think about going to a production environment where in a lot of organizations, developers don't necessarily have access to control the configuration of the application and production, right? A lot of times, you as a developer, there's an operations person and there's a wall there and they set all the values. And so the nice thing about a key vault is if you say, hey, as part of getting the application to run in production, all you have to do is update the key vault credentials and all the other configuration associated with that simply needs to be set. You give them the schema that it's going to be set. Then they update 3 values. That's what it takes to change the values associated, connect to a key vault, and away you go. The application runs happily ever after. So in this particular case, I have 2 secrets in my key vault currently, or 3, I guess. So I have something called API accounts URL. So that's the URL that we were using a minute ago to connect to that service when I got the exception when it wasn't running that showed me the employees associated with me as an employer. And then I have my Azure B2C information, which as my application moves, the policies can go, but as you may have noticed, the application IDs are going to actually have to change. So I've stored that in a key vault already. So so the Azure B2C has the idea in applications of any given application understands where the redirect is going to go back to. And so I can only use one domain. So in this particular case, this was payroll sample.azurewebsites.net. And then the employer portal, this is my local development, it's HTTP localhost 32.769. I can only, within this particular application, associated application ID, redirect back to something that's on the localhost domain. I can't mix and match, so I couldn't do an azurewebsites.net along with a local host. So the application ID is going to have to be different, so I've gone ahead and put that in my key vault as well. Now, Key Vault, because this is pretty sensitive, we would consider this to be secret data. We generally would not want our Key Vault information stored in our app settings.json because the app settings.json by default gets checked into source control. So in ASP.NET Core, we introduced the idea of user secrets. So you right-click on a project, you say Manage User Secrets, and it brings up a secrets.json file that is stored in my users app data folder, so it will never accidentally be checked into source control. And so what I'm going to do is I'm going to move my Key Vault credentials, because I don't want these in the application settings.json, into the secrets.json. So that has that information. And then what I need to do is I need to go into my program.cs where I'm leveraging, so ASP.NET Core has built-in support for working with Key Vault. So all I have to do here is say add user secrets and give it the class that I'm currently in. And with that, one line of code and simply copying and pasting, I should see that I'm still correctly getting my information from Key Vault. And in order to test that, I'm going to delete this account service URL because I've stored it also in my Key Vault. Let's go ahead and delete that. And the name of that I changed just to prove that I was really doing this. It's API accounts URL. So if I go into my application where I try to access that, which is the employees page, I'm going to go ahead and account service URL. So you can see I'm using the name of the key in Key Vault. I'm not using the name of the key there. And when I hit Control F5 to launch the application, we would expect that the application would continue to work as expected, even though we're now loading our B2C key or application ID, and we're loading our Key Vault Connect credentials from Key Vault. So it's just another way that ASP.NET Core lets me, as a user, really quickly work with secrets. Azure helps me get set up with authentication, and away I go. Perfect. So that was our first demo, and there's just a brief review of a couple of things we talk about. I also talked about the user secrets.json file, which is in Visual Studio as well. All right, so the next thing, as we're getting ready to think about this application, we have it working well enough that we can start to think about testing it and moving it to the cloud. Because as we develop for the cloud, I think we're going to find that it's going to be a lot faster overall to sort of progressively move the application to the cloud. One of the things we're going to want to know is, how's the application functioning? How do I debug issues when it's in the cloud? And so the nice thing that we've done in .NET World, Visual Studio, and Azure is we've created some really great diagnostic tools. So we have overall service health monitoring, which does layer by layer analysis of your application. And you can see the overall service health of which layers are failing. We have automatic correlation of logs and exceptions across HTTP calls. So this little application that we have, we'll look at that here in a minute, has two services right now. It has the front end portal, which makes an HTTP call to back end, and they speak JSON back and forth across that. Snapshot debugger, how many people have seen the snapshot debugger? Okay, not that many. This is, I think, really, really cool. So we'll look at that very briefly, assuming my internet connection works well enough. And then the cross-level analysis performance of production. So there's a lot of things in Azure. It's like 2 button clicks, and you can turn on most of this stuff, and then it's really easy to use. So with that, let's go back to our machine. All right, so the first thing I'm going to do to start working with some of those things that I just did is we need to take our application, we need to move the application from our Visual Studio development machine up to a location in Azure. Fortunately, Visual Studio makes that really easy, so I'm going to right-click my employer portal, and I want to say Publish. And this is going to bring up the Visual Studio Publish page. I already had a profile existing. We'll go ahead and create a new one for the purposes of this. And so what it's going to do is it's going to let me pick where do I want to publish that application. As I mentioned today, I'm going to focus most heavily on Azure App Service just because of the really clean getting started experience. So I'm going to go ahead and we're going to create a new instance of an Azure App Service. It's going to pop up this publish dialog, which will do a little bit of spinning because it's very asynchronous dealing with the cloud. So it was one of those things I probably should have pre-warmed up in hindsight, but that's okay. All right, so I have my subscription. It's my Visual Studio Enterprise subscription. Let's pick a good name for this. Let's call it Payroll Ignite Talk. And this is going to be, the app name is going to then be .azurewebsites.net. My resource group, let's go ahead and create a new one. If you're not familiar with an Azure resource group groups are very conceptually similar to a folder. So if you think about developing locally, you have a folder that you put everything in. The idea behind a resource group is you put all of the resources associated with your application into the same resource group. And then in the cloud, you can actually, we'll notice earlier when I browsed, the way that I think it's easiest to find things rather than going by service is I go to my resource groups. And so I can pick, so Andre Hal Ignite is the one that I had set up for all of my local development working here on my Visual Studio machine. So let's go ahead and create a new resource group. And we'll call this Ignite Talk, and this only has to be unique to me as a user, so I don't have an Ignite Talk one. And as an app service plan, let's go ahead and create myself a new app service plan. So what an app service plan is I'm reserving the size of the resources that I want dedicated to my application. There's multiple sizes, free, shared. We default to standard because standard is the first plan that gives me all of the capabilities that are available in Azure App Service. Some examples of that include slots. So slots are the ability to publish a staged copy, warm it up, and then I can, in the portal, I can say swap slots. So if I don't want to take my application offline while updating it, I can publish to a slot. Let's go ahead and click Create to get this process started. And this will take probably about a minute and a half-ish to go ahead and publish. Are any questions while we're waiting for that to happen? Yes, back there. Okay, yes. So the question was, are other third-party tools available for authentication besides B2C? Yes, absolutely. So one of the things that actually I didn't spend much time on it, but in the new project dialog, there was a link here. Let it bring up. So when I say change authentication, that takes you to our Microsoft Docs page. And on our docs.microsoft.com page, we have an entire page dedicated to third-party and open source authentication providers. So for the purposes of this talk, I picked Azure because I thought it was really easy to get started with, and it's a couple minutes and you're up and running. Some of the third-party ones require you to roll a little bit more of your own, but yes, absolutely, and that's even self-documented within the product. All right, let's see what happened. So one of the things I'll mention, you may notice this preview tag up here in Visual Studio. I don't think it published. I think we may have actually managed to crash the product, which I'll talk about here in a second. So one thing I'll do is for diagnostic purposes, by default, for a publish, we default to release. I generally prefer, because this is for my own development purposes, to set it to debug. It just makes a lot of the diagnostic stuff when I want to debug it work much better. So I'm going to go ahead and click publish and republish those bits with debug bits, which will then just enable the diagnostic stuff to work better. The production snap points that we'll look at in a little bit have done some work to try to de-optimize stuff and make it better. But in general, for debugging purposes themselves, you will always find that a debug build will yield better purposes because the compiler optimizes things that makes it your code less look like what you wrote it. So one thing I wanted to mention was the idea of the preview label up here. So in Visual Studio, if you aren't familiar with it, in 2017, we've introduced the concept of channels. So while the publish is going on, I'll talk about it. It looks like our website is up and running now. But you can have multiple side-by-side instances of Visual Studio. So we have our stable channel, which is currently Visual Studio 2017. Why do you not want to run? That's all right. Employees, there's no. All right, so our application's up and running now. But anyway, so I mentioned we get multiple sides. So we have a stable channel, which is currently Visual Studio 15.3. So Visual Studio 2017's version 15. It's the .3 update. Then if you can download and install the preview channel side by side. So Visual Studio installer. And I actually have 3 side-by-side copies on this particular machine, which you'll be able to see in the Visual Studio installer. So if you go to visualstudio.com/preview, you can always download our most recent public preview, which is currently for version 15.4. And then, so on this machine, I have the public preview, I have the public stable version, which is 15.3, and I also have our internal dog fooding version, which is just a couple builds ahead of the public preview. So that's, I think, a pretty cool capability that you can, depending on what you want to do, run side by side. Was that a question? Or? Okay. Perfect. All right. So our application should be up and running now. We're for some reason getting a 500 error. So the nice thing that we can do in Visual up here is Cloud Explorer. If you've never used Cloud Explorer, gives us the ability to remote debug our applications running in Azure. So I pick my app services up here. I can right-click any given payroll.ignite talk, and then I can say attach debugger. And it should kick off a remote debugging session for my application. That's a pretty, I think, pretty powerful capability for the purposes of doing cloud-first development. And then it takes, again, we're working with the cloud. I think the server farm, I think, is the Southeast US, South Central, so it's like Texas or something. But, you know, as opposed to just having no idea what's going on, the ability to right-click an application and start a debugger is pretty cool. So then when I go into, while that's kicking off, we'll go into our Azure portal, and I will show, so let's do Andre Howe, Payroll Cloud, Payroll. And so I'll get a little banner in the top that lets me turn on something called Application Insights. So I'm going to go back here to the resource group that we just created. Right, gotta refresh these. Ignite talk. And so when I go into here, you'll see a banner that will pop up at the top asking me to enable the Application Insights extension. So this is what powers all the diagnostic capabilities in Visual Studio. It's a service that's built into Azure. So I'm going to go ahead and create a new resource called Payroll Ignite Talk. We'll click OK. And that'll take just a couple seconds to spin up, and that'll help me give me a great portal view of what's going on. And while that's spinning up, we'll go ahead back to our other portal view over here and come back to And I'll show you what an application that's been running for a little bit looks like with the diagnostic capabilities that we have in Azure. Sorry, so we have resource groups. This one's running a little bit. Other thing I'll notice as it pops up here, because it tells me how much credit I have remaining, if you have a Visual Studio Enterprise subscription, so it means if you have a copy of Visual Studio Enterprise, every month you get $150 to play with in Azure as you please. If you have a professional subscription, I don't remember the dollar value, but you also have a fair number of dollars to play with. And it's actually really hard to spend $150 if you're just doing development work in Azure. So it's pretty cool. So I'll go ahead and payroll sample. And this is a copy that I stood up last night, just so we'd have a little bit more data to see what was going on. And so as I go in here, what I want to do is I want to go down to Application Insights, which the bar also pops up and lets me get there. And so I can see all the request information for my particular application over the last 24 hours. And if I go to the portal, I'll get a bunch of views. I can see all the requests. Notice that I was hitting it a couple hours ago. I haven't hit it much recently until just now. But if I look at the app map, I can actually see, so I have this client payroll sample is calling this, which is making HTTP calls. And if I expand this, I can see that my HTTP calls are going to two places, login.microsoft.com and the payrollaccounts.azurewebsites.net. So this is showing me the topology of my application, which is a pretty powerful thing. And so if I have any failures, I can go analyze that. So I can see up here that about 20% of my requests have failed, less than 5% have had a warning, and the rest are pretty good. So as I close that out, I have the ability to go in and I can drill in. I can see my performance, so I can see on average how long my requests are taking. I can see I don't have any current alerts on this particular application. And the analytics portal is really cool, in my opinion. So what it does is it dumps all of the data analysis of this. Now I'm the only user hitting this, so it doesn't have much data currently, into a table that then becomes queryable in Visual Studio, or queryable through this. So if I go payroll ignite, I can do requests, for example. It should have automatically opened this. I don't know why it didn't. There we go. And so that I can actually write queries against my application. And I was expecting as I opened that up for it to actually have actually kicked off some queries. But depending on what I want to do, this is the Custo query language. And so I can actually write queries to do analysis across my application, which is a really powerful way to process my data. So the next thing I want to show, talked about modern DevOps pipelines in Visual Studio, is I feel like once you get to a certain level of scale in your application, that there's a good chance that what you want to do is that you want to actually configure a continuous integration, continuous deployment pipeline. And the idea behind that is that whenever I check in any code changes, it's going to automatically build and deploy that to the cloud for me. So instead of sitting here watching the little publish icon spin on my Visual Studio, which is actually a really great light way to get started, but once I've reached a certain level of commitment, I just want to commit my source code, and then it'll automatically build and set that up. So we've enabled this really easily in Visual Studio now. So you right-click on the solution, you say Configure Continuous Delivery. It's going to pop a dialog. It's going to ask me very few questions. And this is going to use VSTS as the back end, Visual Studio Team Services, if you're not familiar with that. So I pick the branch that I want to deal with. We're actually in the Ignite branch right now, the subscription, and I can decide if I want a new service or an existing app service. And when I click OK, I've already created one last night because this is about a 5-minute process, which is, if you think about what it has to do, is not bad. But I'm guessing you guys don't want to sit there and watch it. And so then when I log into my portal, I can see that I have a payroll definition that every time I check in source changes, I can see the number of builds associated with that. So I had one build that failed. I fixed that, then I redeployed, and I had my second build passed. And so what it did is it stood up a place in the service in Azure for me. And so it'll automatically create the app service, or I can pick an existing one, and then every code commit after that automatically gets built and published without me having to do anything as I do that. So It's another good thing, just as you go through the maturity model of developing for the cloud, that again, we would recommend. And so there's just a brief review of a couple things we talked about. Azure App Service, diagnostic. Oh, that's reminded me. Sorry, there's one more thing I wanted to show, which was snap points. And I mentioned that those are a pretty cool thing. So I'm using a VM here. The hazards of working on preview software is the snap point stuff works on a technology called alpha packs, which are very tightly coupled to a very specific build of Visual Studio. And what a snap point is a snap point lets me as a developer set a breakpoint. When that breakpoint gets hit at production time, so I right click on this particular application, so I'll go ahead and say attach snapshot debugger. All right, let's try restarting Visual Studio. As I said, no good deed goes unpunished. You will always have problems during demos. But what it does is it will actually create an in-memory copy of that particular process, and then it lets the application continue executing. So you're able to, as the developer, navigate to that just like you hit a breakpoint in the application. You can inspect the entire process state that you have at that point, but the application is still running, and it's still responsive for all the other users. So if you think about remote debugging from a user perspective, normally, nothing like credentials expiring. Seriously, I just logged in this morning. These security devices almost never work, but let's see if it'll actually work for me, because otherwise I have to go turn on my phone, because they make us enable multi-auth authentication. It's gonna work, maybe? Hey, it worked. Really? All right, so snap points, what you do is you're able to, there we go, finally. You're able to right-click on a thing. You can say, pick your app service. So I mentioned Cloud Explorer is kind of the gateway for dealing with Azure and Visual Studio. So we'll pick the Payroll Dev AS. This is the one that I had my CI/CD pipeline set up on. So I can right-click. I can say attach snapshot debugger. And what this is going to do is it's going to set up. It's going to use application insights. So it has to have application insights enabled on that. And it's going to attach it. And then I have the ability in my editor to go set breakpoints. And then I can say apply the breakpoints. I mentioned it goes and puts that snap point. When I hit that piece of the application continues, but I am able to navigate to it in the diagnostic tools window. I'll show that here in a minute. So you can see that I'm in debug mode. I have this diagnostic tools window up. So let me go ahead and open a file that I care about. I should have opened the solution first, but that was my mistake for having to restart it. It's all right, we can pick our portal, our employer portal, because that's the one we currently have deployed. So let's pick a page. We'll do index.cshtml, which is the same place we were before. And now, when I do this, sorry, I should have needed the solution open first. That's my mistake. Got thrown off by the all right, now, snapshot debugger. So how it works is I will set a breakpoint here. Then it asks me if I want to start collecting, so I click the green thing, and then you see the diagnostics window over on the right side. And then what it does is all my snapshots show up there, and so I'm able to then navigate to them. Any questions while we're watching lovely cloud spinners? Nikhil, do you know why it's not saying start collection? It looked like it had the solution open, or is that just the folder that's open? All right. Sorry. Failure on my part. I apologize. Like a good error. I think it's a really cool technology, though, which is why I'm persisting with it. So application insights, I mentioned, will let you navigate to, and you can see all your exceptions in the portal, and you can get a stack trace for this. This lets you actually get all the variable values associated with those. All right, perfect. So note to self, you need the solution open. All right, so now we should hit our portal. So I had to warm it up. So what happened is I hadn't actually hit the portal, so there wasn't anything. So now when I refresh this, I should see a snap point appear. And so I can see that I have this snapshot. I'm going to say view snapshot. It's going to take me to it just like hitting a breakpoint in Visual Studio. So the modules window is down here. I can see the modules that were loaded in the process. I have my autos, which will populate here in a second as it finishes loading symbols. But you'll notice that the application remains fully responsive, so I can keep refreshing it even as Visual Studio is in the process of navigating to and letting me debug that particular application.
So it's going to create a snapshot every time that gets hit?
It will create a snapshot every time that gets hit unless I turn it off. And so we also have the ability to enable conditional breakpoints. So for example, so let's go ahead and load symbols for my thing because I have just my code on. This one was deployed optimized. And now if I go to my locals window, you'll see that I have local variables, so I can inspect values on this. The autos window is the same thing, but as I mentioned, the application continues to remain responsive as a user. So, perfect. Let's get moving. I see we're quickly running out of time. It goes faster than you'd think. All right. Question, yes? The question was, does the diagnostic tool allow you to capture the state of your database? So we don't have snapshots on database. It will allow you to capture communication within your application, but it doesn't. We don't currently have the diagnostic tools baked into Visual Studio for database. Depending on which database it is, you need to use the tools associated with that particular database. So you can see the values from within your code. That's correct. So application insights will show you outgoing requests, but it won't necessarily show you what happened on the database side. So you would see the outgoing request and you'd see what came back from the database, but you couldn't necessarily debug the stored procedure, for example, if something went wrong there. So the next thing I want to show is serverless computing. So this is called Azure Functions in Azure. And the idea is that it's event-driven. So for example, if you want to process data as it's pushed into storage, you can set up a function that will trigger based on that. And then the nice thing about them is that they will scale indefinitely, so you can set them on a dynamic plan, so they'll spin up instances as they need, but you only have to pay for the resources that you use during execution. So the way that that works in Azure is you're paying for, I think it's RAM times milliseconds that it executes. They have some formula like that. But if you have a function that doesn't do much, you're going to have a really tiny bill. If all of a sudden your app gets really, really popular, you have a bigger bill, but it's going to scale and it's going to handle that load. Unlike dealing with VMs or other instances of things where you have to have some level of control over that scaling, functions will just do all that, and it's all event-driven. So let's go ahead and look at functions tooling. So as I mentioned, in this particular application, eventually we're going to have the ability to generate a pay stub. And what I want is an Azure function that is going to take the pay stub that's generated, and it's going to stick it in a database and then send an email to the employee that I want to pay. So we're not going to do the email thing, but we'll do the sticking it in the database. So we're going to go ahead and add a new project. So in Visual Studio 2017, starting in update 15.3 and then 15.4 is the current build that I'm using. When I go here, I can choose Azure Functions. Let's go ahead and put it in my source API folder. And I'm going to choose an Azure Function project, and let's call this func.paystubs. So now I have an Azure Functions project. And so I need to do two things off the bat from Azure Functions. So one thing really. So first thing I need to do is I need to plug in a storage account. So a couple ways that I could get this. I've already created one up in Azure. So I'll show Azure Storage Explorer. I think is a really good tool for working with Azure. I obviously get the same data from the portal, but this one lets me do it locally without having to go to my browser. And so that'll go ahead and come up for me as in a couple seconds. And Storage Explorer is available across all my platforms. So I've created a local payroll storage account, and then I've created a queue on that for pay stubs. So the idea is that my application, my front-end web service is going to push the application, the pay stub that's generated, the JSON, into a queue. Then the function, whenever something gets pushed into the queue, will simply pick it up and automatically insert that into the database for me. So let me go up here. I need to grab my connection string. And so every Azure function that isn't an HTTP trigger requires a storage account to back it. And so in this particular case, I'm going to go ahead and just paste this into my local.settings.json. And you can see by default, the way that we've set that up is it's excluded from Git. So git ignore is going to automatically exclude the local.settings.json. And then the next thing I do, I mentioned I want to put it in a database. And I'm going to use the new Azure Cosmos DB because that's pretty cool. It's for working with JSON data. So we'll call this my Cosmos DB connection string. And we'll get a value here in a little bit. So we'll go to our Azure portal. We will go, I mentioned my resource groups. Go back. So Andre Hell Ignite. I've created my Cosmos DB. Grab it right there. And I just need to grab the good news, pre-rolled. So we'll get the connection string here in a second while that finishes loading. And so what I can do is I can add, I need to right click on my function project. And I say add, new item. And I choose my Azure function. So let's pick the name of this and we'll call this paystubs.cs. And when I say add, it's going to pop another dialog that's going to let me pick the trigger type that I want. So I can see that there's a bunch of trigger types here in Azure. So I have a blob trigger, event trigger. I'm going to go ahead and pick a queue trigger. And my connection in this particular case is going to be Azure Web Job Storage, which is the name of the key that I just put in local settings.json. Let's go ahead and click OK there. And then, because we can, let's go to our branch, wrong thing, branches. Let's switch back to my master branch that has everything that I want. Oh, fine. Changes. Blah, commit all, branches, master. All right, perfect. So this has our Azure Functions project. Wait while Visual Studio reloads some projects. Oh, right, because my thing got included. Sorry, we'll switch back. All right, so now when I go to my function project, I'll see that I have my pay stubs thing here. So the next thing I want to do, and this is one of the really cool things about functions, is I just use attributes to do new things. So I want to add I need to add a NuGet package. So I say manage NuGet packages, and I need to do webjobs.extensions, which is going to give me the document DB extension. Let's go ahead and choose our latest stable version here. Accept. Perfect, so now I should be able to, in here, if I say using Azure document DB, and so what I can do is I can add an attribute that's document DB. I have to give it a couple different values, which is the name of my collection, which I have in here. So if I say overview, so I can see I have databases pay stubs, the ID is call, pay stubs, comma, call, and then I'll say connection string setting equals, what did I call it? Cosmos DB. And then let's give it, this is going to be out, dynamic document. And it's all I should have to do in order to connect this up to Cosmos DB as soon as I go get my connection string out of the portal. So I'll go to keys. So I'll grab my primary connection string, copy this into Visual Studio. Let's go into my local settings.json, Cosmos DB. And assuming I have wired everything up correctly, when I run the application, I will set a pay stub. So we'll put head at, so what I want to do is I want to say document, document equals, and I just want to assign this the myQ item. So that's going to be JSON that the application is going to push into this particular thing. So if I look at my portal.employer, when I go to my pay stub, I can see that as a user, basically when I click, there's a button that I can push that says release pay stub to our user. So let's go ahead and launch this. And while that's spinning up, let's go ahead and start debugging a new instance of the functions, because I forgot to add it to all right, so we'll go ahead and sign in. All right, so I'm going to go ahead and generate pay stub. Now when I click this button that says send to employee, what this is going to do is this is going to push that into my queue. And so when it pushes it into the queue, if I look at Storage Explorer, while we're waiting for it, I should see that there is a message indeed in the queue. And then Visual Studio here, I didn't, I forgot to put my breakpoint in here. That could be a problem. So it should have already been processed probably. So refresh. Still there. So there's a timing on these things, so I can go update that in this host.json. So I can say, and we have full schema support here, so I'm going to say queues, max polling interval, and this is in milliseconds, so let's say 500. That means it'll update at least every 500 milliseconds. Debug, start new instance. And assuming I connected things up correctly, it should get hit. Oh, I see the problem. So I'm looking at the wrong queue. The name of the queue is pay stubs. I'm looking at my queue items, so that's why we're not having any success there. Debug. Perfect. So now I can see that I got the JSON blob, that's the pay stub, out of there. So now when I hit F5, simply by doing this attribute binding here in functions, I now expect it to show up in my Data Explorer in my Cosmos DB. That's a pretty easy way to interact with Cosmos DB, I think. And you can do this for all sorts of, most of the services in Azure now have function support. In fact, you even see down here in the Cosmos DB portal that there's an Add Azure Function button. So it takes a couple seconds to load from there. So for the sake of time, we'll go. But you can take my word that it'll, and so I can see that I have 2 pay stub records, one of them being the one that I just pushed in a few seconds ago. Cool. All right, so let's move on. So we talked about Azure Functions, talked about Cosmos DB. So the next thing I want to talk about is containers. So how many people here are working with Docker containers currently? Not that many people. So the idea behind a container is that it takes all of your application and dependencies and packages them at runtime. I think when we talk about this at Microsoft, we are envisioning that probably within 5 years, containers are going to be considered best practice within the industry. So what happens is you build your container, and everything, the application, the dependencies, and even the copy of the runtime are pushed into that container. And now it's this immutable blob. Just like you build an executable from source and you deploy an executable, a container packages everything. So if you're a .NET user and you need 4.5 for some reason or 4.0, a container lets you run that application using 4.0 or ASP.NET Core 2.0 or ASP.NET Core 1.1 forever, and it can be side by side on the exact same machine with a container that has a different copy of the image. And Microsoft releases images that are, so we have Windows Server images, Windows Server Core, there's Windows Nano images, and so every time there's a security update for Windows, we push an update to what's called the base image. Your application has a base image that it points at, and then all you have to do is rebuild your application and you get all the benefits of all those security updates. So we ship a security update to the .NET runtime. Instead of figuring out how to patch your server, you just rebuild the image, redeploy the image, and you have all the security updates. So the nice thing about containers is containers are kind of a virtual machine without all of the downsides of a virtual machine. So if you think about a virtual machine, you bring an entire copy of the guest OS with you in order to get the benefits of isolating your application from all of the other applications that are running in different VMs. What a container does is a container, as I mentioned, packages your application, the runtime, and all of its dependencies into a thing, into a single package, into a single container, but then that sits on top of a container image. So instead of having to bring an entire copy of the guest operating system with you, a container basically lets you get a much smaller package relative to a VM with all of the same benefits of a VM, and you still absolutely have isolation and get the ability to scale. All right, so the last thing I want to talk about is the ability to deploy through a container registry. So containers, right, it's this big unit, and so how do you get it from your local development machine to a cloud environment like Azure? And the answer is it goes through what's called a container registry. So Azure has one, it's a hosted service, Azure Container Registry. Docker Hub has them, or you can stand up your own private instance. And so what you do is you publish the container image into a container registry. It's called a Docker push operation. And then on the other side, the cloud, you basically poke it, and it does a Docker pull, and it pulls that image out of the registry back down to where you want it to go. And in Visual Studio, starting with 15.4, which is the version that's currently in the preview channel, we've added the ability to directly publish to Azure Container Registry. We've always had the ability to publish to the Azure Container Registry for App Service. So if you wanted to use an ASP.NET Core image, a Linux image, and work on App Service Linux, we've had that ability since we shipped Visual Studio 2017. But what's new in 15.4 is the ability to go to a container registry, and then you can go into the portal or use other tools if you want any other environment. So there's lots of other environments that run containers that we don't necessarily have the ability to directly publish and provision everything from Visual Studio. Two of those would be Kubernetes in Azure, and then Azure App Service. And as I mentioned, you can grab the slide later. There's a link there, and I have it at the end of the deck as well. But Microsoft publishes images, so you can go get SQL Server images, you can get Windows Nano images, you can get Windows Server Core images, you can get ASP.NET images, ASP.NET Core, WCF. Microsoft produces lots and lots of images you can use as a base image to build and run your application on top of. And the last concept to talk about within containers is the idea of an orchestrator. What an orchestrator does is it handles multiple containers, and it defines how they work together. It coordinates the deployment, their availability, their scaling, and their networking. And so last demo that I want to show for the purposes of today is how do you enable work with containers in Visual Studio. So you have to install container tools for Windows, or sorry, Docker tools for Windows, and so I can see that I have that already installed and running. They support both Linux and Windows images. Right now I can see that I'm in Linux mode because it offers me the option to switch to Windows containers. So I just right-click on a project. I say Add Docker Support. Ask me what OS. We'll go ahead and go with Linux because that's what my Docker for Windows is in. And it's going to go ahead and add that container support into my application. And then I can go up here to my API application as well. I can say Add Docker Support Linux as well. And so what it's done is it's created, unlike before where I was having to go into my solution and configure multiple projects for launch, what it's added the idea of a Docker Compose project here. And every time I right-click on a project and I say Add Container Support, there's also a checkbox during new project creation if I wanted to start with Docker at the beginning. Oops, that's what I want to do. That's what I wanted to do. Control-Shift-N, .NET Core, .NET Web Application. So I had the idea of I can check this and I can say enable Docker support and I can pick my operating system there as well. So it closes my solution as I do that. But that's it. All you have to do, right-click, and now F5, Control F5, debugging all work. And once I have my application up and running, so you'll see here that I can, now when I right-click and I say Publish, and I say Create New Profile, you'll see that I have new options. So I have Azure App Service Linux, or I have a container registry directly. If I choose container registry directly, I can choose Create New Azure Container Registry, an existing one, Docker Hub, or I mentioned a custom one. And so what we think this does is we think that this enables everyone, no matter what you want to do, to get containers from your local development machine into a place that they can be used in any environment, regardless of whether we directly target it from Visual Studio or not. As I mentioned, there's several different container orchestrators. So we have Azure Service Fabric. You may have heard about that. It's been around for a while. So that's currently the only place that supports Windows containers in Azure right now that's in a RTM supported state. So Kubernetes currently has a preview support of Windows containers. But if you want to use Linux containers, you can basically run those anywhere. App Service that we were looking at, I was kind of recommending as a getting started place, today currently only supports Linux containers. They don't support Windows containers at this time. So if you really want to scale up and run your application at scale, we would probably, if you don't have an opinion, recommend that Kubernetes is probably the place that you want to be. As I mentioned, Windows is in preview, but they're aiming to RTW it by the end of the year. So, great. We're almost out of time, so I'll skip the questions for now. Feel free to come up and grab me after the slide. There's several related sessions. As I mentioned, this is was kind of an overview session. The idea was to give a broad overview. So there's a talk tomorrow about how do you take existing applications that are written in .NET and migrate them to the cloud. And it's all about containers, so modernizing existing. There's an entire session on snapshot debugging. There's an entire session on implementing microservice patterns. And then there's a session on DevOps as well. And resources that I mentioned. So we blog about all the stuff that we do at aka.ms/webdevblog. I mentioned the .NET architecture page. Go grab that ebook. It's a great resource. It's free. And I have links to Docker images, .NET Docker images, and then how do you install Docker tools for Windows. Because Visual Studio requires that. When I right-click Docker support, I would have gotten an error if I hadn't installed Docker tools at that time. All right. Thank you, everybody.